Right on this computer. Here we go. All right. So how we finished up yesterday, like I said, a little additional challenge for you guys is to finish creating the other types of checking accounts and how to create those and add those. And what we realized though is we actually saw a good example of how an interface actually works, how we can easily swap between one another. That's the idea of an interface. The easiest example of an interface in the real world that I forgot to mention last class. Think about anything in your house that needs electricity. If it needs electricity, what do you do with it? If you have a device that needs electricity, what do you do?
Plug it in.
You plug it in, right? You plug it in. And as long as it's an outlet, right, it'll work. Like you can have a wall outlet, you can have a power strip, you can even actually have a battery that as long as it has a power outlet, it will work, right? The electric item like a lamp doesn't really care where it's being plugged into, as long as where it gets plugged into is providing electricity to it, right? That electricity could be coming from, like I said, a battery, could be coming from somebody on a bicycle, one of those manual generators biking around. It could be coming from a solar generator, wind generator, nuclear energy, any of those things. And the lamp doesn't really care. At the same time, the power supplier doesn't care what's taking the energy, right? The energy can be being supplied to a lamp, can be getting supplied to a computer, can be getting supplied to an electric toy, whatever, just something. It doesn't really care where that energy is going as long as it gets there. And the interface between those two systems are outlets, are plugs. So it can, again, wall outlets and your power strips and all those things. That's how interfaces are. They allow these two items to interact with each other without really knowing what the other one is or how it's working, what's going on behind the screen. My lamp is turned on right now. It's plugged into the wall. And at any time, my electric source can go from, let's say my building that I'm in right now has a battery backup system. At any moment, my building that I'm in could easily switch from the live electricity from the city to the battery, and my lamp won't care, right? Doesn't know, doesn't care. That's that kind of an interface. And that's kind of what's happening here in Maine. At any point, we're just like, you know what? I want to use my console now. I'll just switch back over to the console. And as far as everything's concerned, it all works the same. At any point, I can also switch it right back to chaos, and everything's fine. Nothing changes for the system. None of these systems care which console is actually being utilized. At any time, I can create a new console at any point. The console also doesn't know who's using it or how it's being used. It just knows, hey, I'm a console. Here are my methods. Tell me what you want to do, and I'll give you the code. I'll let you do that, and I'll give you what you want. Do you see that parallel between the power strips or power outlets and interfaces? Hopefully that helps make things a little easier. And so now we know how that works. Do we see that kind of behavior in our account interface? The way we've been using this, does that kind of fit that same behavior that I just kind of talked about, that same parallel fit for this? Or is our account interface not really working like a power strip?
It's working like a useless sub.
It's kind of bundler, right?
Yeah.
It doesn't really feel like it's being used right. And that's exactly it. This is not the spot for an interface. This is where we realize, you know what, every single one of these items is pulling from this, and we never actually use this class. We're never actually instantiating a bank account. We're always instantiating a child class, right? My notes open. Always using them as a parent class, this guy right here. And so what's going to scare some of you right now is that this is actually fairly easy to switch over. So all we're going to do is add 2 words here. That's going to start the process of switching it over. Public abstract class bank account. Oop, not there. Wrong line.
I was gonna say something, but I was like, man, I must really not know how to do abstract classes.
One line. Public abstract class bank account, and we're gonna get rid of this implementation now. We no longer need to implement account. I'm now gonna go to all of my child classes and make sure that that implementation is also gone. Because we now, the one thing it's going to say is we do have this one error here. It's more of a warning because again, overrides are not required, but we're no longer overriding from an interface, so we no longer need the override command. We can keep the actual method. We no longer need that override method. We only need the override here because again, toString comes from the object class. Don't forget that. That actually is something we do inherit. We do get from the object class. So now we switch that over. We now have a bank account, no longer importing from the account class. All of our items are just extending that account. So this is the one thing you do want to keep in mind though. Abstract classes are considered a parent class. And what is that? There's a restriction. There's a difference between that. Let me make sure I want to word this question right so I don't give you the answer. So there's a difference between extending and implementing. There's some restrictions in place on extend that implement doesn't have. So there's a restriction when you inherit versus implement. What is the restriction? I want to remember.
You can only inherit one class at a time.
Correct. Unlike humans, classes can only have one parent. So we can only have one parent. So we can only have one parent class. Of course, we can implement as many interfaces as we want. So we can implement as many contracts. We can sign as many contracts as we want. It's fine. We can say how we can use however many descriptors we want. But yes, we can only have one parent. So do be aware of that. If you're finding yourself you need multiple inheritances, maybe that's something else going on there. But that is good. That is the main thing we want to get over there. So now let's pop over quick to our bank class for a second. Actually, no, we should probably start in client first. Sorry. Start client first because we have account here. And account. All you do here is change account to bank account. That's going to be, that's not descriptive yet.
I think if you just hover over bank account and hit Control Enter.
Oh, right. That's your thing, right? Control what?
Control Enter.
The command enter probably. Nope.
Nope.
It says create a class.
It
You
should
import
let
it.
you
Yeah.
import it, yeah.
For some reason, your system has stopped. Your version of this has stopped letting me do auto imports now. It just imported
That's
twice.
strange.
That's weird behavior. Anyway, now we import it. It's there. If you scroll down, you just got to again find these locations. So I'm going to do a click here now. I can do refactor now. Name. Okay. Good.
That you got, I think
Get
it's
all
hit.
of
Yeah.
them.
Why is it still red?
Hit enter. Exit. Oh, right. I don't want to.
Oh, okay.
One. Yeah. Fine. Yeah. It was trying to get me clarity. Had it here. It was renaming the variable. I was going to. It was telling me that I'm trying to rename it to a variable that already exists or to a class that already exists. I'm like, no, that's fine. It's fine. The client's not okay. So everywhere we had account, we now just have the word bank account. And that's the slight difference here. Bank account kind of does what the interface does. Bank account allows us to do that all-encompassing system. All of this children account can act as a bank account. So we can, by having an abstract class, we can say that in checking account is a bank account, and it literally is, just like how we have the interface system. So similar concept here. We can now use bank account the same way we use the term account. So bank account is now our collection. It's now our encompassing class. It allows all these child classes to act as it is, or as to be under the umbrella of the bank account system. Go back to bank now to see the same thing. I'm going to actually change this over this way. I'm gonna do a Command F. Find a replace this time, actually. Maybe. Match base. Let's replace. Nope, I'll do that. Yeah. Do I really need to do a file find replace? Oh, Command R for that, huh? All right, fine. Oh, I can't. Let me do this actually. It auto imported. Let me do. Stop it. It's auto importing. So why does it want to auto import that?
I'm so confused on what you're doing.
I want to do a find and replace so that I can replace all the references to this account to bank account.
Can you do that?
Yes.
That's awesome.
So, okay, that should work this time. But just so you can see what's happening, I want to leave it like this and see all the green highlights that are happening. So we're changing it here. We're changing it in our hash map of bank accounts. We scroll down a bit. We're going to find in our add account. We're now changing it here to bank account. We're also going to change it here. So this now works because return checking account isn't working because checking account currently doesn't implement account. Note how we didn't actually register this change yet. So be aware we haven't registered the change yet. So checking account is not an account anymore because we got rid of that interface. Checking account is no longer implementing account, so it doesn't qualify. Neither does savings account. We're going to change it here as well under the debit card system. We can still do the account instance. Enter key. Continue. I don't like that. Yeah, it's trying to change the name of the file, isn't it? It did.
Hey, Cliff,
Yep.
line 16. Why is there what is that, a squiggle in between the arrows?
It's just got code in there. Just hiding it because it's unnecessary.
Oh,
Yeah.
that's cool. I didn't know that.
Yeah, I didn't realize it did that too. There was some new update. I don't remember doing that a while ago. Hey, text animate. Let's put it in there.
IntelliJ just does that.
So I'm not sure. There's got to be an easy way to refactor. I think my biggest problem is this thing. Having the term account. That's probably the problem I have because I can't do a Control F or a Command R, find and replace. So I was going to go through and actually replace them all. So here, bank account. Over here, we're going to change this one to bank account. That's going to return. That's what's being returned. Now look up. That was an easy one. That one fixed a bunch of stuff. You can see everything got updated. Like, oh, this is all good now. Checking account is a bank account. Checking and savings are both bank accounts. That's happy. I'm just going to change this one. Bank account. Now that's happy. Note how this still works. So just like interfaces, you can do an instance of. Same thing with abstract classes. You can check what specific class of an abstract class it is, but again, by using instance of. You can say is checking account is our account here an instance of checking account, even though it's a bank account. So it's a bank account, but can be an instance. So we can still do the same thing now. Bank class is all happy now. Client class is fine. Only other one we want to double check quick is debit card. I believe is the only other one we've actually used it in. And there we are. You see it there. So I'm going to use a trick that I just did last time. By doing that, it's going to bring in the other one back or not. Whatever. If you look at the liar, bank account there. Bank account there, and that is it. What's going on here? Why is this not going up again? Oh, doesn't need that anymore. There we go. Oh, that's what you did. Go away. Here. Oh. Add account. Client class. You're using the wrong one, aren't you? All good? All good. Okay. Be careful with the refactor system. It can be a little iffy. So, why did it delete the other? Okay, that's weird. All right, I'll just probably bring that back later. Oh, I know what I can do. From here, git checkout, git status first. I'm going to delete the file. There it is. So here's something that's really useful. If you made changes to a file in your Git, you want to undo those changes, especially like we deleted it for example. There's something you can do called git checkout as well. Even though checkout checks out branches, you can also do it to check out existing files or staged files. So you check it out back to the original version. So you do, for example, git checkout, paste the file we want. Why not? That's weird. Nope. Okay. That's why we can check it out. I don't know. Let's bring it back now. Nope. All right. I'll just download it later. Actually, we don't even need it anymore. I was actually going to delete it anyway, but I didn't want to delete it yet. So interface is gone. We're now using the abstract class. That's it, actually. We've actually done all our code. So all we did was add the word abstract here, remove the unnecessary override from this one because it's no longer an override of the interface. And then we went, oh, there it is, back now. Took you long enough to come back. The git checkout there worked. Good. And then we just went through our account or items and just switched any reference to the account interface to the bank account abstract class. And it worked pretty much the same way. So this allows us to do the same thing. So again, anytime you have multiple classes that are all doing the same behavior, that are behaving the same way, and are really implementing a class, not just an interface, that are going to be hot swappable, we're not going to randomly swap these out. I'm not going to suddenly randomly swap a checking account for an investment account, right? These are different things. They're similar, but very, very different, but they do have the same root behavior, the same root item that you're not going to use independently. That's where the abstract class comes into play. Like I said before, I'm never going to go and get a dog. I'm going to get a specific type of dog, right? I'm going to get a certain type of dog. I'm going to get a specific type of dog. But when I say dogs, we all picture like everyone here is going to picture a dog, but we're only going to picture dogs. And there's going to be one or two people that are going to picture wolves too. And that's something you got to remember. We have the dog family. So there's wolves, coyotes, dogs, Labradors, all of them. They all fall under the dog abstract class, right? And that's that idea here. You're never going to go out and just be like, I'm going to get a dog. And that ranges everything from wolves to coyotes to anything else. Like, you don't just have a dog per se. You have a type of dog, either a homebred dog or a mutt or a wolf or a coyote. There's something, right? Or a fox. They all have. There's certain types of dogs out there. So when you get your pet dog, that's usually a domesticated dog. That would be the class that would follow under dog, if you want to be very clear about it. You have the dog abstract class, which includes foxes, wolves, domesticated dogs, coyotes, all of those. And then you would have the domesticated dog class, which is where you would then bring in your Labradors and your Schipperkes and your terriers and all those, pugs, right? Even then, you could probably even dig those down deeper into more abstract classes. You have your retrievers, you have your Labradors, you have your pugs, you have your mutts, you have all of those, and you can put those into abstract classes as well until you get down to those root classes that you're actually going to instantiate. Sound good? So take a look at this. What's
Sounds
going to
good.
happen? Like I said, what's up?
I was just saying that sounds good.
Oh, cool. Okay. I was like, I missed the question. And so this is the finish to our bank account class system structure. That's pretty much what we're going to build. Everything else now moving forward is going to be part of application building, Spring Boot building. But you still want to take all these concepts, these understandings of abstract classes, interfaces, and such with you to Spring Boot. What's going to happen is next week, I'm going to pick a day and we're going to assign the final OOP challenge to cohort 11. So that's something you guys will be working on in conjunction. That's something the challenge you'll have. The goal is to try to finish it in the week. All right. This challenge, you want to include interfaces and potentially an abstract class. So you want to try to utilize some of these advanced features of them. You'll have a week to work on that. So it's not something you have to get done in one day. You can still kind of work on that while practicing, while planning your lesson. But that is going to be a challenge you're going to have. I'm going to give it up next week. I'm going to put it up next week. I just have to decide what day I want to do it. I've usually been doing it on Thursdays. Maybe this time we'll do it on Monday and see how that works. But this is going to be your final like OOP challenge. Just let me know how you're doing with the Java. It'll also let me know if you need to slow down on the lessons. We do some follow-up lessons and dig a little deeper into the challenge. What also may happen for those who do struggle with this challenge, what may actually end up happening instead is that I will give you the video access to cohort 8's review of the next challenge. So the next challenge, cohort 8 already did it. And all I will hint out is that it's going to be a card game. So I will leave with that. What we will probably do on Monday then, just so that I have something before we have Jim dig in. You know what I actually might do? Jim, I may actually have you go Monday. Tuesday, we'll have a dive into kind of example what card game interfacing kind of looks like. So I'll give everybody the challenge on Monday. You'll do your lesson. And then on Tuesday, we'll give a gap for whoever's got to go second. So I'll let you know, again, as soon as we kill the call, I'll let you know who the second person is. So
Okay.
So can I ask a question?
Go for it.
Now, maybe I zoned out and I just didn't notice, but did we declare any of these methods abstract?
Nope.
Now, so I guess what I'm kind of getting confused with is abstract classes are interfaces and classes in one, but the class cannot be instantiated, correct? Is like a way to put it?
Yeah, it can't be instantiated. It has all the behaviors of a class that can't be instantiated, where an interface doesn't have method bodies.
Yes. So with an abstract class, you can declare methods abstract. They don't have a body, and then they have to be implemented
you have
in
to
the
implement
class.
them in the child classes.
Child class. So in this case, we don't actually have any abstract methods. Would it be, not that it would make more sense, but would it be more useful to just have the interface that way, because we're not actually using anything that's abstract aside from just not instantiating the class and all it's inheriting? Or would it just be useless to even have an abstract class or an interface and just
In this
have
case,
it be a parent class?
In this case, just again, how we used it,
Mhm.
you're not really benefiting from the advantages of the interface.
Okay.
Because we're still every single one of these classes is all implementing from this class, which extending this class, the bank account class, which implemented account.
Yep.
So you had one class implementing the interface and all the others just got that because of the children. So it kind of seemed redundant. And we weren't hot swapping these, which is one of the big benefits of interfaces, that you can just hot swap them through, as you saw us doing with the UI system. You'll actually see another example of that when we get into the cards. I'll actually show an example of that as well. It's one of the other lessons I can do. So, and even then, depending on who the second person is there when you go Tuesday, you might hold that class for that lesson until someone's stuck. Might even hold it till Thursday, maybe. We'll see. I'm not saying which day specifically. So you'll see another example of an abstract class before we finish up, dealing with cards. But
seems like the abstract class is related to all light classes versus an interface you could use multiple different classes and still have the same usage of each class, even though they're different for an interface.
Yeah, as you know, our console class and our chaos class are completely different on how they implement. stuff.
Right, so
We
that's
get-
why you use the interface for that because they don't really have similar things.
No.
to Make it into an
They
abstract.
have the same methods, the same actions, but how they do those actions are completely different.
Hmm.
Whereas the investment account, the checking account, the investment account, and the saving account all have a deposit method, withdraw method, and get account number, and those are very, very similar. They have slight, very small variations, and so we can benefit from that. We know that with one of them, with our two-string method, we started adding on overrides to just add in a little bit extra, but they all use the exact same two-string method, and they actually borrow from the parent class. Even a couple of them with our withdraw method, we did the same thing. We added on a fee and then called the withdraw method again with our investment account. We added on the $1,000 unit fee, but we still called the parent withdraw method. So these are very, very similar in how they function, with just slight varying differences, just the daily limit system and all that. So overall, that's kind of what your big difference is, that a lot of these four methods, these four classes are very similar to each other, thus the bank account, while still having their small variations. Whereas Chaos and Console, they implement their behaviors extremely different. They are very, very different. And the only thing that they share is the action name. That's it. And that's kind of
So
what you're getting.
how does super in a constructor work with abstract classes?
Super refers to the parent class.
Okay.
Yep.
So you
That's it.
have super in the bank account?
Not in bank. Bank doesn't refer to as parent class. It doesn't have a parent class anymore.
Oh, but your constructor's there though.
I'm not sure what you're saying.
Public bank accounts is constructor, right?
Yeah.
So, but you're not
You never
using,
instantiate it.
yeah. But I mean, where does, I'm just trying to figure out how does super, using the super under some constructor to use
It
all those.
refers to the parent class. That's all it do. It just refers to the parent class.
Yeah.
So in checking account, we use it to just
Oh,
refer
there's
to
your
the parent
super over
classes.
here in your child account. So you're using them on the
Yes.
in child to grab from the parent.
Yeah.
Okay.
If we referred to super here, we'd be referring to the object class.
Yeah.
So super.toString would be something we could do.
Right. But so the child classes have the super in the constructor, but
No,
because they're inheriting it from the bank account, right?
nope, take a look.
Oh, wait.
They're passing
It's
information
provided through the
to
extends command. The
the-
extend commands provides the super, but
But
all classes have the super command built in, again, earned from the object class. So
Okay.
the object class is what gives it, but it's actually just a keyword. It's not actually a variable or a class. It is a keyword. That's why it shows up orange.
Yeah, but I know it pulls in from it
So
allows
it's
you
not
to use the other.
It's not a
other
variable. Hold on. It's not a variable. It's not it's not a variable. It's not a field. Nope, that's purple. That's white. This is similar to this. It's a keyword. So you don't have to define it anywhere. It's not defined anywhere. It's not created or instantiated anywhere because it starts in the object class. Just like this, just like the phrase this, just like public, just like void, just like if. We don't declare these words anywhere, do we?
No, I just was trying to figure out like using that, and then you use it in the child classes. You don't, you don't use it in the parent class, but you had these before.
Again, hold on. You're messing it up. You can use this in the parent class. I can use this in bank account.
Oh.
Bank account has super, but it's going to refer to the object class
Oh, okay.
because bank account is still a child account. That's why we can use this override command here. I still inherited the toString method from my parent class object.
All right.
Just a quick tip. So in IntelliJ now with a recent update, those O's and arrows on the left side, if you hover over it, it says where it's overriding from or
cool.
to. So you can see that it's overriding from object and then it's overridden in other classes. So that's pretty
Yeah,
cool.
Yeah. So if you were to refer to super here, you would be referring to super, the object method, the object class. So I could say at the bottom here, right here, I can even do an add super.toString. Perfectly fine. Super is a keyword of Java, not a variable, that is just exists in the Java syntax. And it just refers to the parent class, whatever parent class is, this is a child of. All objects you create, every single object you create, by default inherits from the object class. As long as you have that keyword. The class keyword is what triggers that that pull down from object. The thing that overrides that default inheritance of object class is the extends command. So the extends command says, don't inherit from object, inherit from this class instead. So I could, if I wanted to, explicitly say extends object.
Oh, okay.
I can do that. It's going to mark it as unnecessary. See?
Yeah, because it's yeah.
It's redundant code.
Yeah.
But that's where super comes from. Super is just a keyword. Just like this, just like if, just like public, just like void. That's why it's orange. Sound good?
I got one more question, and I hate to
Go
keep
for it.
class going longer, but
No,
it's
go
kind
for
of
it.
confusing me. So,
Questions are important.
okay, in client, we are creating hash maps of a string for the account number, and then we're storing bank account objects,
Mhm.
right? So the accounts are being typecasted to bank account when they're being
Abstract
stored.
class.
Yeah. So bank account has a body in its methods. If we were to
Mhm.
call bank account dot withdraw, would it use the bank account withdraw? Or would it use the checking accounts
It'll
withdraw?
use whatever, yeah, it'll use the class that's actually there. So if
So it's
the
bank
item is,
account, correct?
yeah. So if
Hmm.
we have a checking account, it's going to use the checking account withdraw. All
Even
that
if
the
it's
bank account
typecasted
abstract
into
class
there?
does is guarantee that there's a withdraw method. So it'll,
Okay.
and just remember, checking account, sorry, what is it? Let's take a look quick. So checking account doesn't have a deposit method, right?
Yep.
Nope, you're wrong.
No. Yeah.
It technically does have a
It
deposit
does,
method from bank
because
account.
it's extending bank account.
Right.
Okay, so
That's
what
that
if
slight difference. So that's a good thing that you pointed out. Interfaces do not provide methods, does not provide items down, doesn't give the items. All an interface does says this item will have the method.
Yeah.
An abstract class actually gives the method to each class, and that's why it can be considered a guarantee. I can guarantee in the client class, I can guarantee that any account in this hash map will have the withdraw and deposit method because of that inheritance of the bank account class, abstract class.
all right,
Or
so
yes, if I want to use a checking account or a savings account specific method, I
Yeah.
don't have to typecast it.
you have to typecast it. Okay, see, that's
Mhm.
why I was getting confused, because of the fact that bank account, like, would it make more sense to give those methods that are being used, make them abstract, and then force the body being formed within the classes themselves that are inheriting from it? Or if it's needed, because if a class doesn't actually declare it within the child class, that it can actually inherit from it and use the parent class's method. That's why I was confused.
Like I
Because
said, the only real difference between a abstract class and a class is there's two differences. One, you can't actually implement it.
yes.
So you can't actually instantiate it. That's it. That's one thing. That's the first main difference. And two, the other big difference is that you can utilize it as an umbrella class. So it can
Okay.
encompass all the child classes that actually are inheriting from it.
Yeah,
You can do it
I guess I
once.
was just saying that I was confused as to, like, if I knew I was storing a checking account in there, but
Mhm.
it's right now it says a bank account in this hash map, and I did bank account dot
Yeah.
withdraw, I would have to make sure that I'm using a checking account withdraw if I wanted to do the right method, to run the correct method.
Again,
the correct
depends. Withdraw is a bad example because withdraw is not a checking account specific method.
function. Okay, yeah, that's
Right.
true.
It's going to automatically run the withdraw method of the class that's in there. It's not going to run the bank account withdraw method. It's going to run the withdraw method with whatever's in that class. If the class never overrode the withdraw method, then yes, we'll use the bank account method, which I think, which one of these?
Oh,
Yeah,
so that
savings account, for
override
example.
actually declares and lets Java know that to use this instead of the one that's
Exactly. So you see in
okay.
savings
All
account,
right,
there is
all
no
right, that's
withdraw
making
method.
more sense.
So
Okay.
notice how on savings account, there's no withdraw method. So when
Mhm.
I call savings account, or when I call account.withdraw, and let's say that account is a savings account, it's going to use the bank account withdraw method because it got the savings account inherited it. It's there. You don't see it in the code here, but it's there because of this.
Mhm.
And again, as far as client's concerned, it doesn't know that it's getting the bank account withdraw or the checking account withdraw or the savings account withdraw. It's just saying, hey, this class, it's an account, whatever's in here, whichever one I grabbed, use this withdraw method. I know you have it because bank accounts have it. All I know is that you are a bank account. I don't know which specific bank account you are. I know your bank account, so I know I can call the withdraw method.
All right.
If I want to use the savings account specific apply interest method, I don't know for sure if my bank account has it. So I need to check, say, hey, are you a savings account? Yes, you are. Okay, now I'm going to ask you to apply interest
the
method.
instance of, that's where instance of would come into
Exactly.
play to make sure that you're actually in the right account. Okay. All right. That makes more sense.
Good questions. Any others while we're at it? Don't be afraid of them. These questions are good. I'm sure everyone here is like, oh, that makes more sense. Hopefully.
So I just want to get this straight. So you can have all the methods in the bank account because it's parent, and then you can have quote unquote overrides of those methods in the individual, like a savings account. If I decided to say, hey, you know what, if you wanted to withdraw $5, I'm going to give you $50 from the bank, even though that wouldn't make sense, but I can make an override in that account. So when you withdraw from savings, it will give you that, it would override the bank accounts, the parent's class.
Yeah, which we did in
like the checking account you said?
checking account and also investment account in the investor account.
Oh yeah, with the amount right
we
here.
applied a fee.
Yeah.
So we applied a fee. We still called the parent bank account withdrawal method, but we applied a fee to it too.
Okay. Yeah.
So we said, you know what? No, if you're gonna withdraw money from this, we're gonna charge you a fee.
Yeah. So yeah, so you can, yeah. All right.
Yep. Any other questions?
No, but the abstract class is like, it's like the base, it's like the base object. This is like the foundation of this object, and we're just building little pieces off that
Yep.
will use that foundation.
And because these are items that we do commonly bundle together in collections, that's part of the other main benefit of the abstract class. If these were always going to be solo items standing on their own by themselves, we wouldn't need the bank account abstract class. Technically, we could just keep it as a class. Because we want to be able to bundle these under a collection of bank accounts because they all get stored together, that's where the other big benefit of the abstract class comes into play, is we can use the bank account in a collection and all these items apply to that. They can all be safe. It makes those things savable. Because again, it tells our computer system what it can and can't do at a glance with these. It tells us, this tells the system, these are the guaranteed methods you can run with no concern, no fear whatsoever. And then of course, like I said, any of the other ones, we can just typecast to make sure that we are allowed to do it, and then we can do it. So it gives us that ability to bundle all these similar minded classes together for what's that word that's talking about bundling like-minded items? What's the pillar for that?
Oh,
Got a 25% chance. So. Encapsulation, right? Yeah, very good. Encapsulation, we're encapsulating these things. So bank account, the abstract class is an encapsulation tool. It allows you to encapsulate all these similar minded classes. So you can bundle them together, encapsulate them together. Any other questions?
Yeah, one more.
Go for it, Christian.
Okay. What would make you decide a parent class of being abstract or not? For example, if you have, like this instance, you have 4 classes that are all inheriting from one parent class. They all they might not all do the same thing or not.
I will clarify, by the way, we only actually have 3 inheriting directly from bank account.
Okay, yeah, my bad.
CD inherits from investment, which doesn't invest. Exactly. But yeah, I see
what would make you have to decide that this one doesn't need to be instantiated and can be an abstract class?
Well, the way you'll realize it is because you've never instantiated. That's one thing. Have we ever instantiated the bank account after we created the child classes? Once we started creating the child classes, we never had a use for the pure bank account because it wasn't descriptive enough. It didn't really make sense. And so that's one of those big key items. One, you'll realize I'm never instantiating this. And then you're also going to at some point realize, ooh, I need to be able to store multiple different classes together in a list or in a collection of some kind of an array, a list, or I need to store any one of these, even just one of them. Because I could also just do in, let's say, client, I could have, again, right here, saying bank account, primary account. And what I'm saying here is that as a client, I can have any of these 4 accounts be my primary account, be my main account.
Mhm.
that I refer to when I go to the bank and when I go to the ATM, when I go on my mobile app, this is the account that'll pop up first. So any account can be considered my primary account. It doesn't have to be a checking account. It doesn't have to be an investment account. It can be anything. So it's not just for listing. It's just saying, you know what? In this field, I can have any bank account here. I'm going to store one of them, but I can use any one of them. There's no specific class it's going to be. And so, you know what? I'm going to make it more abstract by saying it's going to be one of these classes. And you know it's a bank account. Which one specifically? Not sure. But it's going to be one of these. So I use this abstract class as a way to allow myself to put whatever I need in. It gives me more dynamicism in my code.
Got it.
Good questions. Any others?
Yeah, I have a question.
Go for it, Elaine.
So if you're doing like the dog thing and you start out with dogs and you've got all dogs, then you do domestic dogs, why are you breaking that down into smaller and smaller groups?
One can also be for one readability and again, encapsulation and abstraction. By doing more breakdowns, it helps me to find where something goes wrong. I can just jump to that specific item where the problem could be. And it saves me from having to do repetitious code in the branching classes. So in for the dog class, we have bark, we have run, we have wag tail, all that stuff. While in the domesticated dog class, I can have sit, I can have certain domesticated dog behaviors or methods, train, things like that, that are specific to domesticated dog. Because you can't train a wolf really. I'm sure you could, but it's way more difficult. But you get the
Right. And so you might have like a domestic dog that hunts, and you might have a domestic dog that sits in your lap, and there would be, that's why you'd break
Kind of.
it so that you
Yeah.
could have just the one.
While
one
still
type.
sharing all the behavior, all the similarity between the hunting domestic dog and the yippy domestic dog, the one that just sits around and yips out the window all day. So those two dogs still have similarities that they share,
Right.
right? And that's where that abstract class parent comes into play. I don't have to write the same code in both those classes because that code is in the abstract class and the two child classes inherit from it.
All right.
Good questions. I like this. Any more? And again, you can always save them for Monday. It's fine. If you come up with more questions, please ask them. I think we're good then. Awesome. So I'll load this up again. Last thing I'm going to make sure it's clear what's happening. So I'm thinking on Monday, I'll give to cohort 11 the final OOP challenge. For anybody who does struggle with that one and doesn't complete it within the week, what we'll do there is you'll be tasked with having to watch the cohort 8 videos on how we solved it, and how we did the approach. Same thing we just did with Liar's Dice. I did that exact same thing with cohort 8, so you'll be able to watch through it and code through it and actually get that lesson still, while the class can still move forward. So you won't be held behind. You'll just have a little more extra work to do to keep moving forward. What we'll do for you though is we'll pause the final project for you. You'll just be asked to hold off on the final project till you can go through the video and do a second OOP challenge. So you'll still have the same kind of situation there. So if I do notice you're struggling with the OOP challenge, it's not clicking for you yet, you're not getting the interface, whatever it is, that's what we will do with you. So you won't be losing out on anything, and we won't hold back the entire class if a couple of you have struggled with it. So don't panic on it. If you can't figure it out, you can't figure it out. But at the same time, you want to do your best to figure it out so you don't fall more behind and you can get that job sooner. You'll be able to, like I said, this is one of the things where you can get breadcrumbs from your coworker, from your classmates. You don't do peer, you want to be very careful doing pair programming, but you can get breadcrumbs. If you're stuck beyond all help, ask for help on these. It's completely doable to finish this OOP challenge. I'll give you guys within a week. All right. All right. I'll see everyone on Monday. So over the weekend, like I said, I'm going to try tonight or at least tomorrow early in the morning, early in the day. I'm going to try to give out a list of what your topics are so you can start digging into your topics or topic.
Can I hire you for a little bit after the class, bro?
Yep. All right. I think
Are
that's it. So
wait, you're reassigning the
mostly cohort 11 only. So unless you, Joel, unless you gave me a new list of you want to potentially change your group because there's some new topics, if you don't send me a list, you get priority because you have seniority and you're probably already working on it.
Okay.
So if there's a student that really wants your topic, I may ask you if you want to keep it, but most likely you get priority selection.
all right,
So,
okay.
I just was it you who had two?
I had a rest.
You had two, right?
No, I think I had like 4.
Darius, wait, you should only have two. No one should have more than two topics.
Oh no. I thought you meant like through the list, like what number?
Oh,
Had two. Yeah, I had two topics. Yeah.
you did have two. So I want you to let me know which one you would prefer to keep mostly. So organize those two. Let me know which one you're more interested in doing.
The REST API would be. I'm fine with that.
Yeah, just send me a message so I have it so I don't forget.
Okay.
Yeah, send me a Slack so I don't forget which one you selected. I will forget. I'm not like my memory is weird. What it decides, remember what it doesn't. So, yeah, send me a Slack which one you prefer to keep. And again, if I have a student that wants that one, I'll message you to just confirm. And if you say you want to keep yours, you keep yours. You have seniority. So. Any other questions? Awesome. I will see everybody on Monday. Have a good weekend.
You.
Take it easy.
Bye.
Bye, buddy.
Oh, I don't know if anyone else is staying for the final project, but did you still want to talk about that?
Yes, stay.
All right, cool. Dope.
All right, send you the thing, Cliff.
Thank you. I'll talk to you Monday, Joel.
Oh, that's
Will,
so
got a
cool.
question for me at all? Are you hanging around for a reason? You probably stepped away from the computer. I turn up to my
You talking to me, Cliff, or somebody else?
Nope, I was trying to get Will. Ah. So Christian's here for another reason. Titus, what you got?
I just wanted to take a look at something what I'm working on. I'm having an issue with a connection with the npm MySQL. I'll share my screen.
Go for it. We'll see if that goes quick. Let me turn off my share screen. Hold on. Share.